Okay, this is the third video. This is going through, we're going to go through Unit 5, Systems of Linear Equations, Bundle 1 of 2, but I just want to follow up on the last question of video 2. It asked, the Scholarship Association gets an order 12 student tickets, 10 adult tickets. Can the Scholarship Association afford this many tickets? We did it mathematically on the other video, and I just wanted to show you here. You could actually just look at student tickets is 12. You can go up to 12 and go over to 10 adult tickets. Oh, I'm sorry, student tickets are down here. Go to 12 here. Go up to 10 student tickets, which would be here. Since this is outside of the shaded area, this would not be a solution. Okay, so moving on. Bundle 1 of 2, formulating and solving systems. For each table, write an equation in slope-intercept form, which is y equals mx plus b. Then solve the system. So we're going to, first of all, find the slope. In order to do that, we can use y2 minus y1 over x2 minus x1. If this is my y1 and this is my y2 and this is my x1 and this is my x2, I would do 7 minus 5 over 2 minus 0. I would get 2 over 2, so my slope would equal 1 for this equation. So in my equation, I would have y equals 1 would be my slope, so that's the number that goes in front of my x. Then I need the y-intercept. When x is 0, that gives me my y-intercept, so I'm just going to plug that in. X equals, or y equals x plus 5. On the next problem, if I go y2 minus y1 over x2 minus x1, this is my y1, my y2, x1, x2. I'm going to go negative 2 minus 0 over 0 minus negative 2. And negative plus a negative is a positive. So I get negative 2 over positive 2, which is going to equal negative 1. So my slope in this situation is negative 1. Now, if you didn't understand how I got 0, 5 as my y-intercept, this is what you would do if you needed to solve this. If you did not see that, then this is how you would solve it. You would say y equals, my m I can plug in as negative 1, which is negative 1x. Then I would take my equation, y equals mx plus b. I can then substitute in one of these y values for my y, substitute in my slope for my m, substitute a x value for my x, and solve for my b, my y-intercept. So I'm just going to go ahead and take this one, this set of ordered pairs. So I'm going to say negative 2 is my y, m is negative 1, x is 0, plus b. 0 times negative 1 is 0, so I get negative 2 equals b. So my answer is y equals negative x minus 2. Because I've now substituted my b here, my m here. Okay, so in order to solve it, I can do one of two ways. I can either use elimination or I can use graphing. So either one would work. I can do it both ways, but I'll show you how it works. So if I were to graph it, in order to graph y equals negative x minus 2, I'm going to go down to my y-intercept, which is -2. My slope is -1, so I can go down 1 to the right 1, down 1, -1, +1, -1, +1, or I can go +1, -1, +1, -1. Then I'm going to take my ruler. I don't have my favorite ruler, but here is my other ruler, and I'm going to graph it. Then, so that is this one. Then I can do the same here, and I'm going to use this as my y-intercept. So up 5, 1, 2, 3, 4, 5. My slope is +1. If you want to do that, you can do that. You don't have to. +1. And you're going to go up 1 over 1, up 1 over 1. This is positive up, to the left, or to the right up. Positive up, to the right, positive. Or I can go negative and negative. Negative down, negative, because I know a negative over a negative equals a positive. And I notice that they do not meet exactly on a point. In fact, they meet exactly in the middle of a point. So when I look at that, I'm going to say that is 1, 2, 3.5 is my x, -3.5. and +1.5. So if I wanted to solve this by elimination, I see that I have a positive x, and I'm sorry, a negative x and a positive x. So I see that I can easily add these together and it would cross out. And I would get 2y equals -2 plus 5 equals +3. Divide both sides by 2. Y equals 1.5. And that's what I got there. Then when I substitute in y for y, I get 1.5 equals, I'm going to put it into this one here, x plus 5. And I'm going to subtract 5 from both sides. 1.5 minus 5 gives me -3.5. So there it's solved in both ways. You can solve it both ways. Since it's as a graph here, it's asking for a graphed thing, a graphing. I want you to notice though, this was in slope-intercept form as opposed to standard form. And I still used the elimination. Because I can put, as long as I can put it right on top of each other and I have all the same lineup, I can do it that way. Alright, moving on. Find the solution to the following system of equations by graphing these two lines. So I'm going to graph this one first. This is my y-intercept. I go up to 2. My slope is the number in front of my x, which is 1. So my slope is going to be 1 over 1. Positive 1 over 1, which means I go up 1 over 1. Or I can go negative, 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 negative. As long as both are positive or both are negative, I will be having a positive slope, because a negative over a negative is a positive. Same with this one. If I have y equals negative x minus 2, I go down to -2. My slope is negative, so I want to make sure that my line is going to be going in the negative slope direction. So I'm going to go down 1, which is negative and a positive, negative and a positive. Or I can go positive and a negative, positive and a negative, because I know as long as one is negative and the other is positive, that's going to give me a negative slope. One has to be negative in order to get a negative slope, but not both, because that'll give me a positive slope. So the solution here is x is 2, y is 0. Oh, I'm sorry. X is negative 2. Negative 2, because it's going in the negative direction. So hopefully you caught that error. On the next one, I'm doing the same thing. I'm graphing these two inequalities, except the difference is now it's in standard form, and so I'm going to need to change it into slope-intercept form. I do the same thing every time. When I move it from standard form to slope-intercept form, I am basically solving for y, meaning I'm trying to get y by itself. I'm trying to get y on the side where it's by itself. So I'm going to do x plus y equals 6. And in order to get y by itself, I'm going to subtract both sides by x. I get y equals, I cannot combine these two because one's an x and one is a 6 without an x in it. So it's just negative x plus, because the 6 is positive, 6. So I can graph this now because it's in slope-intercept form. My y-intercept is 6. My slope is negative 1. I go up to positive 6. 1, 2, 3, 4, 5, 6. I plot my point. Then I can look at my slope, and I see that it's negative 1. So I'm going to go down 1, positive 1, negative 1, positive 1. Negative 1 is my rise, positive 1 is my run. Or positive 1 is my rise, negative 1 is my run. Up and to the left, as long as one is positive and one is negative. There's the graph for that one. To graph this, I do the exact same thing. I'm going to subtract x from both sides, and I get negative y equals, I cannot combine these two, so I keep them separate, but I have negative y. So in order to get rid of that, I need to divide everything by negative 1 in order to change my signs. Mostly I care about this sign. So I get a positive y, which is exactly what I need. This also changes positive because a negative over a negative becomes a positive. A positive over a negative is a negative. To graph that, I'm going to go down to negative 2, and my slope now is positive, up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. And I see that they intersect at this point right here, which is 1, 2, 3, 4, positive 4, and positive 2. Okay, now moving down to number 4, we have 2x plus y equals negative 4, negative 3y equals 2x plus 12. Which graph can be used to find the solution to the system of the equations below? So which of these have the lines that match these two equations? So I take 2x plus y equals negative 4. I need to move that into slope-intercept form, just like we did up above, except for this time we're going to just subtract 2x, subtract 2x. This cancels out. I get y equals, I cannot combine these two because one has an x in it and the other one doesn't, so that's negative 2x minus 4. So this is one of my equations. Then I go to the next equation, and I get negative 3y equals 2x plus 12. that's close to y-intercept form except for the 3, the negative 3 that's there. So I need to get y completely by itself, so I'm going to have to divide everything by negative 3. And these cancel each other out. I get y equals 2/3, which is a negative, because a positive over a negative is a negative, x, plus, this is going to be a negative 4. So I jumped the gun and put a positive. That should be a negative 4. 12 divided by negative 3 is a negative 4. So then I've got to look and see, okay, which of these graphs down here, both of them intercept at negative 4. This one has the y-intercept at negative 4. It's the only one where both lines have the y-intercept at negative 4. If you wanted to look and make sure, you could look and see, okay, this has up 2 over 1. So that would be a negative 2 or a positive 2 over negative 1. That matches that. Or up 1, 2 over 1, 2, 3. Or down 2 over 1, 2, 3. And that has a negative 2/3 slope. And this one has a rise, run. So 2 over 1, which matches that. Okay, moving on. Number 5. Let me do this. Which of the following graphs best represent a system of equations that has no solution? So the key here is what has no solution. When are these lines ever going to cross? And here I can see none of the lines except for this one cross on the graph. So we can automatically take that one out. What I'm looking for are parallel lines, because parallel lines never cross. These are not parallel because you can see there's a slight tilt. These are parallel, which they would have the same slope. Okay, moving on. The bill for 5 glasses of apple juice and 4 salads is $9.50. The bill for 4 glasses of apple juice and 5 salads is $10.30. What would be the bill for a glass of apple juice and a salad? So we're going to write the equations. If I know that apple juice is an X and salad is Y. If I have 1 glass of apple juice, I'm going to multiply it by I'm going to multiply the amount times the number of glasses. So it would be 5 glasses of apple juice, 5 times X, plus 4 salads, 4 times Y equals $9.50. So 5 glasses of apple juice times the cost of each apple juice plus 4 salads times the cost of each salad is going to give me $9.50. The next one is 4 glasses of apple juice and 5 salads is $10.30. So 4 glasses of apple juice times the cost of the apple juice plus 5 salads times the cost of the salad is going to equal $10.30. So in order to solve that, we can use the elimination. And in order to get these the same, I can multiply 1 by the opposite. So since I'm looking at these and I know that I need the same number with an opposite sign, and I have none of that in this. I have this, and the x and the y have the same number, but that doesn't help me because I need the same variable to have the same coefficient in front of it. So I know that 5 times 4 is 20, and if I can get both of these to 20, then I'm going to be in good shape because I'll have the same coefficient in front of my x. So I'm going to do that. I know if I multiply 5x plus 4y equals 950 times 4, that will get me 20. So when I do that, I get 20x plus 416y equals 9.5 times 4 is 38. Then if I take my second equation, 4x minus plus 5y equals 1030. Now in order to get that to 20, I'm going to multiply it by 5. However, I don't want positive 20, I want negative 20, because then they'll have the same number and a different sign. So when I add them together, they will cancel each other out. So I need to multiply by a negative 5. When I do that, I get negative 20x minus 25y equals 10.3 times negative 5 is negative 51.5. So the reason I can multiply this by any random number is I'm not changing the integrity of the equation as long as I multiply everything in the equation by the same number. The ratio of the equation stays the same. We can do this. We can multiply everything in the equation by the same number. So then, now I've got everything lined up. My x is on top of my x, my y is on top of my y, and my constant is on top of my constant. So then when I add them together, these are going to cancel out just like we want them to. That's our whole point, is to eliminate one of the variables, which we have successfully now done because that's 0. Then when we add a positive 16y to a negative 25, I'm going to get 9y, negative 9y. When I take 51.5 and I subtract 38, I'm going to get 13.5. And that would be a negative because the 51 is larger than the 38. So that's a negative 13.5. Then I need to get my y by itself. I divide by negative 9. Divide by negative 9, and I get y equals 1.5. So what that's telling me is that the salad is $1.50. Then when I plug this back into my equation to find out what the cost of apple juice is. So I can take any equation. Let's just take 5x plus 4y equals 950. And I can plug my y in. 5x plus 4 times $1.50 equals 9.5. I'm basically just substituting this in for my y. And then I get 5x plus 4 times 1.5, which equals 6, equals 9.5. I'm going to divide, or subtract by 6, 5x, I get 0 here, equals 3.5. 3.5 divided by 5, x equals 0.7. So that's telling me that apple juice cost 70 cents. What is the question asking for? What would the bill for an apple juice and a salad be? So if we add those together, if we take an apple juice plus a salad, we add them together and we get $2.20. So there's your answer. That's the end of this video, and go to the next video for the rest of the answers.